Welcome to Embedded. I am Alicia White. I'm here with Christopher White, and our guest this week is Adam Wolf. We're going to talk about kits and projects, and gosh, I'm not even sure, but I'm sure it will be fun.
Hi, Adam. Thanks for joining us.
Thanks, everybody. Hi.
Could you tell us about yourself?
Sure. I'm Adam Wolf. I am an electronics engineer. I graduated with a computer engineering degree, worked at a large engineering company for a few years, and then went into a design services. So I did a lot of projects for other companies in a company that basically acted like a contractor. So a lot of times we would help projects wrap up for like when places would get stuck. Other times we would help start projects, and other times we would work throughout the whole project. And then in the middle of all that, I said, I want to do some engineering outside of the job. So a friend of mine and I, we started this thing called Wayne and Lane about 10 years ago, where we just worked on microcontroller projects for a while. And then we found one that a lot of our friends are like, that's pretty sweet. I would buy one. So we made some, and we became like a company and went from there. So outside of that, the company made a bunch of kits. We still sell kits. We do a lot of contracting for like museum exhibits and interactive installations. We do the hardware and programming and interactive design, for lack of an easier word, I guess. And then with kind of like to fill the gaps there, we really like this program called KiCad or KiCad, which I will slip and call it KiCad a lot, but it's KiCad. And we help work on KiCad. So we package it for Mac OS. We've added some features. We help fix bugs, things like that.
All right. I forgot to say in the beginning, we're going to be talking about KiCad. Now I'm really self-conscious about it. But before we get started with that, lightning round, are you ready?
Yes, I am.
Werewolves or vampires?
Werewolves.
Have you ever licked a 9-volt battery?
Oh, yeah.
Favorite component?
LED.
Surface mount or through hole?
Surface mount.
Most frustrating Lego brick?
Anything that's only in one or two kits.
Favorite fictional robot?
Baymax.
If you could teach a college course, what would you want to teach?
If it's one that exists, I'd say Introduction to Microcontrollers. If it's not that, how about one on like how to take notes or to have like a knowledge base of your own?
Do you have a tip everyone should know?
Sure. Write down all the things you're interested in and all the projects that you can think of, and you'll be really surprised by how often you'll see things that relate to them, and how easy it is then to make everything you do in engineering like satisfy 2 or 3 of the things you'd like to do.
Okay. I like write down your ideas. Maybe we'll talk some more about that.
Yeah.
One more short question. Why is recording a podcast a dad thing to do?
A dad thing to do.
I refer to your tweet in which you...
Yes. Yeah. So to me, I guess I wouldn't say it's exclusively dads, but dads definitely record podcasts. Like, it's not only dads that record podcasts, but dads, it'd be like I think having a podcast about your smoker is a pretty dad thing to do. like smoking meat or
Right.
Or right. I think that's pretty dad, right? Like we could talk craft brews and how to smoke meat at home. Like that's pretty dad, right?
Okay. Let me ask you about Wayne and Lane. Are you Wayne or Lane? I never really understood that part.
Yeah, sure. So me and Matthew, we met maybe in 6th grade or so. We went to high school together, went to college together. And it was sometime, we had known each other for maybe 10 years before we realized our middle names rhymed. So now the InfoSec people out there are probably like, oh my gosh. But yeah, so I'm Adam Wayne Wolf and he's Matthew Lane. And so I am the Wayne of Wayne and Lane, and he is the Lane of Wayne and Lane. But what's kind of nice is that when we were like earlier on, like there'd be times that I'd have to make a call up to like a supplier, or a person would call me about like an invoice or something like that. And like they'd call and I'd be like, this is Adam speaking. And they'd be like, well, I'm just wondering about payment terms on this. And I'd be like, well, I can ask my boss, but I'm not really sure. And so if it was Adam Wolf Engineering, it's real hard for me to answer the phone as Adam Wolf and say, oh yeah, I'm not really sure. I'll have to ask the boss. But as Wayne and Lane, it's like, oh, me, Adam, I could be anybody.
You are your own employees.
Definitely.
Virtual employees.
What was the first kit that got you into selling things?
Sure. So we made a tactile metronome, or tap tempo metronome. So this is basically a PIC 16 a piezo element. It has a display, I think 3 7 segments, some NPNs on there, battery holder. And it was pretty nice because you'd tap the piezo and it would pick up the rhythm that you were tapping into it. And then it would play that back to you. So if you wanted to tap, say like the shave and a haircut into it 3 times, it would keep playing that back to you out through the piezo element.
And so that would be audible, not tapping you. You're tapping it. That's the tactile part, not
exactly.
Okay.
So the person who made it would be tapping it with a pencil or their fingertip or something like that, and then it would start up and start chirping at you, and then I think it even had 2 buttons up and down to change the speed, to change the tempo of it. But actually, interestingly enough, I believe we changed the name to Tap Tempo Metronome because we actually got some legal hassle over it being a tactile metronome because it sounds like a famous type of equipment line from Germany.
Oh.
I don't super want to go into exactly who it was or anything, but yeah. So then we after an expensive back and forth, we're like, how about we just rename it? They're like, oh, sure, that's okay.
What are your current kits?
Sure. So we've got a pretty big handful of kits. We actually have only retired 1 or 2 products, but we've got a suite of Lego kits. So these are things that, Lego Mindstorms has had a few incarnations. They had a bright yellow one. They had their NXT, which was their version 2. They now have EV3, and then they even have this like WeDo type thing, which is kind of analogous. But around the time of NXT, a friend of mine came to me and Matthew and said we should write a book where we everybody loves Lego and everybody loves Arduino, so let's smash them together and make a book. So John has written, I don't even know how many books, 20 books maybe, something like that. And so he goes, I've got the book side and you guys can work on the projects and we can have this awesome thing together. So we spent over a year not necessarily reverse engineering, because almost all of the Lego stuff was open, but it wasn't necessarily fully documented and there weren't really hardly any example projects. So we created some interface hardware between Lego and Arduino and then made maybe 8 projects in a book with like step-by-steps. And we had intros to Arduino in there and things like that. So at this point, we have a Bricktronics shield. So that's what we called our product line here, was Bricktronics. So we had a Bricktronics shield that plugs into an Arduino Uno that controls some of the Lego inputs and their motors. And then we had one for the Mega that has more outputs. It's just got more pins on it, basically. And then we have one that just controls motors, and it just has like a driver and then a few pins, and that can just plug into anything. Outside of the Bricktronics stuff, we have these Blinky kits that I think are possibly one of my, I think it's the favorite kit we've made of mine. So these are standard, like it's either like a POV style, wave the LEDs in front of your face and see like a design or a word, or a Charlieplexed a display of LEDs. It's, I think, 8x7. But what we like our little twist here is that to change those, instead of hooking it up to your computer and programming them, or into an Arduino and programming it through there, you hold it up to your computer monitor or your phone, and we have a little JavaScript application that blinks a pair of squares on the screen, black and white, and then through there we have a clock and data, and we have encoded the data through that into in the kit, and then that updates the flash, and then when it reboots, you've got like your new name, like your name is in there or something like that. So it's like that part isn't anything we kind of invented. That's been around since the 70s, I think, was the earliest case we found it. There was that Timex watch that had it. The BBC would even broadcast things overnight for people to like tape a photoresistor up on the bottom of their TV and transmit programs in it in the 80s.
And here I was thinking, oh yeah, I remember Electric Imp doing that, but that was not the 80s.
Yeah, exactly. So Electric Imp had it for like provisioning, I think, for their Wi-Fi, something like that. But I mean, it's been around since the late 70s or early 80s, I think. But for us, so at that time, we were doing a lot of support for camps for schools, like STEM camps and STEM activities and things like that. And the biggest problem we had there was that they were often happening in the summertime when the staff was quite bare bones. And anything that we had that would like that needed driver support was going to be a problem, because almost all these labs were Windows labs, and this was Windows 7 era or earlier, where every device demanded its own driver in Windows. And so in terms of just client support, it's like, sure, they can plug it into a Mac or Linux box and it'll just work, but we needed something that would work for kids, basically without any IT support. And then the other piece is that parents were always very paranoid of, well, my kid just made this and they learned how to solder 18 minutes ago. I don't want them plugging it into our computer. So this is a way to completely opto-isolate it, so that way there's no way they can break their computer no matter how bad of a soldering job they do for their first time. And so for us, like in an educational standpoint, it was this huge winner.
And do you still sell it?
We do. We still sell them on a regular basis. So Wayne and Lane has kind of pivoted away from making new kits for a variety of reasons, but all our old stuff still sells. We still make it. Like they'll be out of stock a little bit more often than they were in the past, but yeah, we still sell our Blinky kits. We did. We took the same exact through-hole kit and turned them into like I Can Solder SMT kind of trainee badges a few years ago, and those they do well as well.
But this is a sideline. This isn't your full-time business.
Well, kind of. So it started out completely as a hobby thing for me and a friend, like basically to play with outside of work. And then we started a business nominally, but it was something that we spent a few hours a week on. And then over the years, we've spent more and more time on it. But at the same point, it was completely a side thing up until I did leave my job, my full-time job, in July, and now I fill my time with a variety of contract engineering things, and it's really nice to have this at this point to fill that spot and to grow the business and to make it into something that I think I'm fairly optimistic that it's only going to be a side thing for a small bit longer.
But you said you pivoted from kits to
something else. Sure. Sure. Mysterious. So yeah. So one of the things is that as we were writing the book, another friend of mine was like, hey, I got in a little bit over my head in a contract, and it's got some Arduino in it, and I understand that you really know Arduino stuff. And I'm like, well, sure, I can make an Arduino do things. And so I got involved in making museum exhibits. And so I work with an outfit here, like, so Wayne and Lane, me and Matthew, we work on probably 30 exhibits a year. And so what that means is, like, we'll meet with the clients, and like, we're part of the fabricator team, and we help them take their dream vision of what experiences they want children or the museum attendees to come away with. And we talk about what technology enables and what options there are. And we have scope to narrow down to, and a budget and a timeline. And at the end of it, it travels around the world often as part of an exhibit on any number of things.
What is the hardest part of doing museum exhibits? Is it making them durable?
So one thing that's kind of nice is I'm only peripherally involved in the durability piece. So that, like, so, I mean, I would say from the grand scheme of things, totally. I mean, this stuff, they're only making one or two of them, and then they're going to have they're going to be beat up on by kids and adults who aren't really trying to be gentle for years and years and years with almost no maintenance. So I'd say that's a pretty big piece. And like for instance, I mean, a few of the problems, I mean, are pretty basic. Like right now I'm working on a project that it has you take the place of a poop scooper at a zoo. And so there's these balls, and you're scooping these poop balls into a bin, and there's kind of like a basketball game type thing involved, right? So as the balls go in, it'll have like a 20-second countdown, and then it's like, how many poop balls are you able to throw into there? And so this is part of a larger exhibit talking about this animal and caring for the animal and all these things. But this, like, small part that I'm working on is a basketball game with fake poop. And the problem we're struggling, or we had struggled with there, was basically, how do we count these balls without making the balls lock up? So like, we have to make a tube or a tunnel where these balls come through and then end up back in the bottom. They can't get stuck because we don't want anybody going back in there. But at the same point, we need to count these balls. So, like, I mean, for that one, we actually ended up with beam break, like IR beam break. But I mean, we also went through like piezo element on like a sounding board. So like, as the balls hit, we would count from the ball hits. Or I'm like, the early ones we had tried for this one were in like the part where we have it in like a tube. We can just have a beam break there for the tube, and that'll be easy. But the problem is, every time every time these things go like into a large area, into a small area, like, the balls will bind up without some sort of like vibration there. It's kind of like a grain bin or anything else like that.
That's a real mechanical problem.
It really is. It really is. It's a mechanical problem, and yet at the same point, all the pieces you have to do with it have to last in the field for a long time. I mean, it's not like we're in room temperature. It does have downtime almost every night if it needs to be repaired. It's not space here, but at the same point, it's also not just electronics in your home either.
Do the museums tend to come up with these ideas or vague ideas and come to you guys and we had an idea for a poop scooper. What do you think?
It's kind of an interesting industry. I don't want to speak too broadly about the whole industry, but a lot of times museums, there's almost like a two-step process where they will dream up a vision and make kind of elaborate artwork and make pretty in-depth plans. And then once those plans are done, they say, well, which ones of these are actually physically possible? Which every time I encounter that process, I always get confused as to why they're not designing for manufacturing at the beginning. But at the same point, they're only making one of these or two of these. So it's not quite the same pressure is like electronics.
Sure.
This sounds really fun. And how did you get into it? I mean, is there a job that is museum thingy creator?
Yeah. You're completely right. It's a lot of fun. It's a lot of me making sure to stay on top of like rapid prototyping electronics. I've worked with a fair amount of jobs where have PCBs and I'm laying out stuff myself and working on projects or SOMs and things like that. And in this world, it's much more, you're going to throw some Arduinos together or some Teensies together or some other boards. So I guess in terms of jobs and how do you get these, a lot of larger museums create exhibits for travel. So a lot of museums make more money renting their museum exhibits out than they do through any other piece.
Really?
Yeah. So it's really interesting to me, but a lot of the larger museums have a fabrication team and they find IP and they get it licensed and then they work on it and they make this awesome thing. They throw their name behind it and then it goes around the country for a few years. And then when it's done, it'll end up in that museum.
What exhibit have you worked on that was your favorite?
My favorite exhibit. Absolute favorite.
We don't want your second favorite.
So my first museum exhibit that I ever worked on is probably my favorite because it got me into this. It got me a network, but it was a exhibit called Powering the City. And so if you've ever seen the Community episode where they were all on the KFC themed space bus, yes. It was kind of like that. So was a fairly...
Sorry. We watched that pretty recently. So
yeah, so when I saw that episode, I was like, this feels exactly like an exhibit that I worked on. So I worked on this project called Powering the City. It was fairly large. It was probably 10 feet long, and it needed a team of kids to get through the project. But it was basically a simulation of 1 or 2 days in this Anytown fake town.
Okay.
So it had a sun in the background, a mechanical sun that moved throughout the day, and it had a thermometer, a physical thermometer that moved up and down to show how hot it was. It had a fan that would blow to show you how windy it was. And all of those were showing kind of the demands of the day. And then there was a power demand curve that was related to those things. So basically in the morning, 8 o'clock, everyone would wake up and they'd start their hair dryers and their toasters and there'd be this power demand spike. And then the day would go and that would kind of flatten out. But then the day would get hotter and hotter and hotter and everyone would need their air conditioning on and then the power would go up higher. And then in the front of the exhibit, there was a hydroelectric dam and the kids could change after the water had filled in the dam, the kids could turn the switch and the switch would then make the water flow down and then it'd make fake electricity. And there was a wind farm that they could turn on. And there was a coal plant and a few other things, but there were 5 ways that people could make electricity. And the whole point of the thing was that if you didn't match that demand curve, the lights in the houses would go on the fritz, or the business, the place that was the factory would spin out of control, things like that. But it was absolutely insane to see going with all it's a lot for kids to do. There's a lot of things going on, but everything's moving, everything's twisting, it's blowing in your face. There's all these dials and switches. It was quite awesome.
That's a really big physical space too, right? It's not talking about a board with some things on it. This is a whole room, right? It was a standard 8 foot by
4-foot table built up was the actual exhibit, and then people kind of walk up to it. I mean, it was an impressive sight to see.
And that one's your favorite. I don't want to say what's your least favorite, but that does sound really grand and lots of things, and yet not a whole huge amount of moving parts. So you can do a lot with electronics there.
Definitely.
Are there ones that you actually no? Let me switch. I don't want to talk about what your least favorites are. That's silly.
No, it's okay. I think there's interesting things there.
What about the ones that you've said, no, maybe physics won't allow us to do that this year?
Sure. So one of the things that's interesting in this world is that the designers and the people creating the exhibits will often want the exhibit to be real. So now that sounds silly to say.
No. You were saying the turbine and it would generate electricity, and my immediate response was, well, why don't you have it actually generate electricity?
That's exactly it. So a lot of times we're asked to do things completely for real. Like, we want to generate the power to turn this thing on. And a lot of times we say, okay, sure, let's do a bench test. Even though we, in our heads, we're like, well, we're going to write that off. But we do a bench test and we're like, okay, so now pedal this bike and we're going to put, 150 watt load on it that you want, or the 200 watt load. Okay, pedal this bike. And they're like, oh, no kid's going to be able to do that. We're like, yep, that's exactly true. So a lot of this is
you have to have them jump on a plate because they're very good at jumping.
Oh, they are. They totally are. Smash this button as hard as you can. Exactly. In terms of kind of least interesting pieces, things like that, it's an interesting world that, like, we did one project where, like, people have wanted to make a power grid. I'm kind of really surprised that everything I could think of is electricity themed, and we've done a bajillion projects that aren't electricity themed. But one that is in my mind is we did this power grid where they wanted the actual, like, power lines in this fake power grid to conduct all the electricity for the project. And at some point, it's like, this is a safety issue. Can we make them be buttons or magnets or something instead? And that works pretty well. And that actually brings me to another really important part that I want to make sure that I have clear to everybody. So, like, I work with a fabricator team that this is their job, is to make safe exhibits for kids. It's really easy to make things that are really dangerous. Like, it's really easy to say, I'm an adult and I don't realize that kids are going to break this off and put it in their mouth and swallow this thing. So, for instance, we did even with this team. So I work with this team here in Minneapolis that they've been doing this for 25 years. And they're a team of like 20 people. But even with that, you'll still find things that slip us up. So, like, we had worked on a project where it was like we were feeding these birds. So it was a project for...
Were they real birds? I gotta know.
They were not real birds. They were these really awesomely machined, like, enameled birds that had mouths and necks that could extend. So, like, the little baby birds were in there and they would chirp and they would open their mouths and chirp and extend their head and chirp. As you got closer, they would extend their head. And you have these little balls that you'd put in their mouth, like, to be like food, that you're a mama bird. And there was like a little glove you'd put your hand in that was like a fake bird. And you would then, like, spit up these balls into bird mouths. Right.
I see a lot of balls being proxy for...
I'm noticing this, yes.
They, it's so funny. Like, I've worked on so many different projects, but right now all I can think of is power grids and things that go in and out of your body. Exactly. But I guess that's why they end up in exhibits. Like, the fact that I can remember them now 10 years later, it's like, well, the kids who went through that exhibit, they sure remember fake puking into the baby birds' mouths. But anyway, so we made these elaborate metal birds. We had everything like through choke tubes in order to make sure everything was good. But what we hadn't accounted for is that kids were going to put their hands down the birds' mouths, and they got their hands stuck in the mouths. Now, like, there wasn't anybody who got hurt in this, but this is something where I would not have noticed this as an electronics engineer, and I would have shipped this thing out. It would have been out there, and there'd be some kid stuck to their elbow in this metal bird as they're trying to figure out how to get out of it. So, if you're into like anybody at home, it's awesome to make exhibit stuff. It's awesome to teach, but also be careful and think of what the most stubborn person who really wants to do an unsafe thing will do with the museum exhibit.
There was some of that when I was doing children's toys too. I remember one toy, it had a big plastic page you turned in order to switch modes. And there was some question of whether somebody would put their hand down, turn the page, and then slam it down on their own hand. And it was just like, okay, yeah, that, I guess. I mean, I don't think you'd do that twice.
That's a life lesson. It's educational.
And so you write the software for these using Arduinos and off-the-shelf boards. Is that because you only have one, or you're only making one of them? Or is there some desire for them to be field programmable?
So 10 years ago, there was no desire for field programmability. Like 10 years ago, if they broke down, they would mail it back to us if it was something small, or we would fly out to wherever to go update some program. Year after year, that's more and more going away, where nearly every museum has a person who can wrangle Arduinos. They might not be in-depth programmers. They might not have degrees in computer engineering, but they certainly are able to take a program and flash it on. So that's part of it. Another part is this stuff is pretty quick turn, surprisingly quick turn. It's pretty low volume in terms of units. The amount of money people are spending on exhibits is fine to do what they need to do with it, but it's fast enough, and the embedded needs are not necessarily so particular that one of a few standard things isn't just completely fine.
I mean, that is exactly what I think off-the-shelf boards should be used for. You don't want to make a custom board unless you have to, and you shouldn't have to if you have a big space and you don't want to make just one custom board. That makes it really expensive.
Well, exactly. And I mean, in terms of electronics, like these things have a lot of weird demands as a whole project. But in terms of the electronics, we're taking human scale I/O. We are in a big old box. We have no size constraints. We are not battery powered. We're not it's not like it will hurt anyone if it crashes or stops working. So it's exactly that. It's exactly the right time for an off-the-shelf Arduino thing. Plus, in terms of kind of ethics, I have no desire to make a product that no one else can ever modify for no reason. If there's a person, 10 years down the line who wants to modify this exhibit, or 5 years down the line, and they've got the source code to it, there's no reason why I should have a one-off thing that, it scratched my itch to make this one board that had one more analog input than the standard Arduino did. So yeah, I guess you won't be able to have any support for that. It's kind of like engineering for after it leaves you as an engineer a little bit.
Do you provide enough documentation that somebody else can take it over, or is it really just come back to you when it happens?
It depends. The particular outfit that the fabricator outfit that I work with has a pretty good warranty. They warranty their products for a period of time. But at the same point, we mail out all the source for anything that anybody requests.
Okay, so the poop basketball.
Yep.
Can you send me the source for that?
So we normally only mail it to the customers.
Oh, okay.
But at the same point, one of the things we're kind of doing is we're trying to productize a few of the more common desires. So like, for instance, so that one right there, the like poop basketball is going to be a Raspberry Pi driven thing because they want, the client wants fancy graphics on a screen. To like, so the scoreboard will be very fancy. So so that'll be a Raspberry Pi, and then that we do almost all of our Raspberry Pi interactives and touchscreen interactives in a framework called Kivy, which is it's a Python multi-touch framework. It's a little bit like Qt, if you folks have worked with Qt.
Yeah. Okay.
It has a thing like the QML feature where it's kind of property based. It isn't the whole program. It also has the Python half, but at the same point, the QML style piece is just a lifesaver for fast prototyping like this. It's a pretty awesome style of programming.
Yeah, that's the thing that Apple's moving to, actually, with their apps, is a descriptive UI language. I use that with Qt, and I agree. I found it really kind of liberating.
Yeah, it feels a little bit like React or Redux. It's a little bit of this like property based piece where it's like I've got the idea of this property, and when I change it, there's handlers, and the handlers will just do their job.
Yeah.
I actually worked on an embedded project for another client recently where they used a tool called Cedux, or a framework called Cedux, which is like a C++ or C Redux style piece that kind of provided that for just C and C++, which I thought was really slick.
How do you know it's called Kivy and not Kivy?
I don't. So I'm going to be completely honest with the KiCad stuff. I call it KiCad. That's what I call it. That's I feel horrible about it because I'm just wrong. Like I'm just incorrect.
Who is in charge of deciding?
Well, so
Jerome
JP,
Key.
So the like first author of KiCad, he says it's KiCad, and so I say, okay, I'll let you name your baby. That's okay.
I'll let you name your baby.
I'll allow it. But at the same point, I looked at it 10 years ago, or 11 years ago, and I said, yeah, I want to use KiCad. It's better than, I think I said Jita at the time. I don't remember. But yeah, the like KiCad is, anyway, sorry about that.
No, it's going to, if that is how it's supposed to be said, it's going to take me about 5 years before I get it right.
Well, the closed source competitor, Yaggle, is,
I did want to talk about KiCad, though.
Yeah.
You contribute to it. Were you a user first, or was this always a software project?
So I think it was late 2008, early 2009. I had graduated from college and wanted to make some PCB stuff. I didn't have access to ORCAD, nor did I want it at the time. And I said, okay, so I need something that's free. And I'm still big into Linux. I was really big into Linux then. And I said, okay, so I need a Linux compatible PCB schematics tool, of which there were two. One was Gita or Jada. I'm not sure. I'm not a user of it, so I don't really know how to say it. And even if I was a user, I wouldn't know how to say it. So then there was KiCad or KiCad. And I installed them both and played around with KiCad first and said, if this isn't going to work for me, I'll switch to the other one. And KiCad worked for me. So I said, okay. So we did all of our Wayne and Lane PCBs with it. And it was maybe 6 months later that we said, we need to add some features to this. This is pretty good, but we need to add some things. So I think the first thing that we added and maybe the only one I can really remember right now, is the hotkey for making a label. So like to label a wire or a net, there was no hotkey for it. So we looked at what keys were available, and L was available. So we said, let's add this in. So me and Matthew added that one afternoon after we'd gotten back from a maker fair. We said, hey, we have a few hours to burn. Let's add this feature. We added it. We emailed it up, and a few hours later, it was in KiCad, and from then on, we were kind of hooked.
How much have you done with it? Is this, you did it once and it was cool, or are you ongoing, or?
Yeah. So my time contributing to KiCad ebbs and flows as time is available. I've got 2 kids, I've got contracting, I've got a career and things like that. So it's not a full-time job for me at all. At the same point, it was about 2014 or 2015 where I took over or resumed the Mac builds, so to make Mac builds. And that's been my primary focus since then. So for about the past 5 years or 6 years, I've been working on the Mac builds. So this means we've got 2 servers here at Wayne & Lane that just build it every night. They build it for a variety of platforms and a variety of ways for macOS. Every time a new version comes out, we have to repackage and figure out what new tweaks there are. Every new piece of software that gets integrated into KiCad, so the fact that there's a spice tool in there, or it works with a spice tool, it works with a few different types of 3D inputs and outputs. It's got a renderer. It's got Python scripting. So for each one of those pieces, I wouldn't say we're the only people, but we're probably the primary people who get that in a redistributable format, so that you can then download it off the internet, and it makes a pretty little installer piece where you drag the application into your applications folder. And that's been our primary focus. And I'd say we probably spend 5 hours a month or more on it, which is not nothing, but at the same point, it's also purely volunteer for us.
I asked on the embedded Slack if people had questions for you, and it turned out people have a lot of questions about KiCad. I don't know if you're the right person to ask, though.
So I've got a list of questions here, and the ones that I saw, I think I can answer some of them if we want to go kind of maybe lightning round style.
Is there an officially blessed KiCad tutorial?
There's a guide for how to get started, but it's not a step-by-step tutorial. I would recommend, if you like video stuff, Chris Gamble has his tutorials. They're called
Getting to Blinky.
Exactly. So go to Google, type that in, and he updates them periodically, and I would start there.
I've gone through that. It's quite good.
I, too, have gotten to Blinky.
Nice.
Carl asks that, Carl says he has some parts for a current project, and what does KiCad need for them to be good enough to go into the library? And is he even allowed to submit parts when he doesn't work for the manufacturer?
So I'll go in reverse order. He is allowed. If you go to the KiCad website and click contributing, there's an option for parts or something like that. And if you click there, it kind of walks you through what you need. Basically, there's a repository on GitHub that you make PRs to. There is a style guide called KLC, which I think stands for KiCad Library Convention. And you'll need to follow those in order for it to get accepted, I think with an asterisk. I think there are cases where you don't have to follow them all the time. But at the same point, the librarians there will kind of walk you through what you need to do to get your stuff accepted.
How does this whole project stay organized? I mean, it's pretty big.
Yeah, it's pretty impressive. So there's a project lead. The project lead right now is Wayne, not associated with Wayne and Lane, but he's an awesome guy. And his name actually is Wayne. He is the project lead, and he helps steer project direction. There is a core developer team of maybe 10 people at this point. I am not a member of the core developer team. And they meet periodically to set roadmaps and to break down work. CERN has some employees that I'm not sure 100% of their current status. I don't want to talk too much to it, but they have been involved. They did a lot of work and advanced a lot of things, like the interactive router that got amazingly better in the past few years was primarily the efforts of the CERN team, as much as I don't want to even say which other things were, because I know it was a massive amount of work that they've helped with. And they are in the process of, I'm not sure exactly the technicalities, but basically creating like a foundation or like an organizing group beyond just some people who spend time together in email. So there's this new organization, I think it's KeyPro, which is run by Seth, one of the core developers, I believe. And actually, Wayne now works for KeyPro, and they provide professional support for KiCad. So they have a subscription model where you pay per month. If you're a company that needs KiCad, there's an option to pay them, and then they have a wish list of features that if you want to vote on, like you get a vote in exchange for this. They support. It seems like a pretty cool thing.
Yeah, and it's always been a very good way for open source projects to sustain themselves, is to provide professional support at cost.
Well, certainly. Cost. Yeah, and I mean, there are people who run their businesses using KiCad. It's like there are times where I'm just astonished, because 10 years ago it worked for what I was doing, but it was not at the quality that it is today. I'd use it at home, but I wouldn't have said like, "Hey, work, we should use this here." But today, I mean, it's pretty great.
Do you have recommendations for using KiCad with source control?
I would say yes, use source control. That's a good thing to use for your projects. In terms of how to use it with KiCad, I mean, the files will work. You can check the files in. It doesn't necessarily make sense to like merge a file that's a design file for an ECAD tool. So if you're using Git or something like that and you want to do a merge, you probably want to take a whole file rather than merge an individual piece. Evil Mad Science did a nice article a few years ago about how to do things on check-in where it will make a graphic of your PCB or your schematic. And then like the human eye and the human brain is able to say, oh, here's what changed, quite easily. There are some tools like that for KiCad. Jesse, the Keyboardio guy, he wrote a suite of tools called KiCad Tools on GitHub. I think I sent you folks the link. And that is it's a nice tool to throw in your pipeline if you have like a CI tool set up, because it can do things like generate a BOM for like a BOM file on check-in. It can do things like create PDFs of your schematic on check-in. It can do a variety of things like that.
Are most of the files that get checked in as part of a project sort of text metadata, or are there binaries that you have to do special things to make sure Git doesn't, the binary blob problem?
Sure. So all of the files for KiCad, all of your project files are all text-based, but they are not necessarily super intended to be human readable. Like a bunch of coordinates is text based.
Sure. Yeah.
Same point, it's not really like something I can just open up and see like, oh, that's a resistor image or something like that.
So those questions were from Tanak. SPE requests, I believe, a way to diff the designs, and says there's a company that does that, cadlab.io or something.
Yeah. So I haven't heard of this CAD Lab. I think it's a great idea. I would like to see it at GitHub and GitLab, and I would like to see those first-party kind of tools. I mean, when I upload a Jupyter notebook, I get to see that in GitHub. I would like to see when I upload a KiCad schematic, I would like to see it as a schematic.
Yeah, me too. And the idea of adding PDFs as you check in is just really, really nice.
Yeah.
It's not that I don't have it installed. It's just that loading it takes longer than loading a PDF.
Well, exactly. And like if you're going to email this to a CM somewhere, you're not going to email them a KiCad file and say, open this up and hopefully it's the same thing. I mean, I'd send them the files, but at the same point, I also want to send them just something they can print and check as well.
One of the things that you talked about earlier was that you love talking about engineering.
Yeah.
Why?
Why?
That sounds accusatory.
Why? I mean, why? Really? Why? No, I mean, I don't mean it that way. I just, yeah. Why?
Why? So I guess there's a lot of different angles for why I like to talk about engineering. One is I think that I have complicated feelings on the engineer pipeline. I think that there's this, like, I feel like there's people who are like 10 years old and say, yep, I'm an engineer, and have this like thing. They were like this. It's like when you see the animals in the Antarctic or whatever just veer off and they're like, oh, they've got a mission. They know what they're doing. And I feel like they can be very scary to other people who are probably super awesome engineers, but just don't have this like innate drive from middle school to be an engineer. And it can be really scary. And so I think just having more people literally talk about engineering to non-engineers, I think is really important. Beyond the having everybody realize that engineering is a thing and here's how we do engineering, I think it's fun. I think it's fun to talk with other engineers to say, what's a tip that you would suggest to everybody? Or I ran into this problem, or I've done all these projects, but I keep having this problem when I invoice. Like, that's not necessarily engineering, but at the same point, if I never got paid for engineering, I would have to do much less of it. So there's all those kind of like the accoutrement of outside of engineering that kind of come with it that help me do more of it. And it's like when I talk about engineering with other people, it's kind of like free experience. I don't have to fail on that project because I heard you talk about that project and what happened on that project and why it didn't go the way that you thought it went. And now when I get into a place like that's a little bit analogous, I'll have this non-failure induced experience that I can draw from.
Thank you for describing why we do the show. That was nice. Do you have any advice for people who want to get into working with museums?
Sure. So one thing you could do is you could go and ask at a museum. So one,
oh my God, really?
Ask them. So it may not be a paid opportunity, but at the same point, a lot of times, if you're privileged enough to be able to take an unpaid opportunity, it can lead to paid opportunities, or it can lead to experience that then drives your next opportunity that is paid. I understand that that's assuming privilege and that isn't something that's open to everybody. Other possibilities are to just work on museum-y like projects on your own. So if you need, I mean, a lot of the problems in terms of the electronics of a museum exhibit, a lot of them are not very complicated. A lot of times the actual electronics part isn't very tricky. So maybe, I mean, if you have an example of a project that could be a museum project and you did it on your own, that sure shows a lot of gumption and a lot of movement. I don't want to sound like a boomer saying walk around to every place with 10 copies of your resume and walk around and hand it in. It feels a little out of touch, but at the same point, there are a lot of museums out there. I think in the United States, there are as many museums as there are Starbuckses. I read that a few years ago. So there's a lot of museums out there, and they're all interested in more content. So that's the direct opportunity. The next would be just to look for museum fabricators. Like behind every nice museum exhibit that lasts is a group of people who made that museum exhibit. So sometimes that's in the museum, other times they contract out, other times they're kind of tied to like event-based businesses. So they're the same type of people that might run a corporate retreat or something like that. And I mean, it's a niche piece of engineering because oftentimes they're not looking for the engineer who writes Linux kernel drivers, and they're not looking for the person who can bang together some STM32 like things in DMA and things like that. And so a lot of times they have an approach from the other angle. So they get these people who have taught themselves enough Arduino to be able to do what they're doing. So if you come at it from the other angle, I think you'll be pretty successful. I have been so far.
So I want to ask you about one more project that I saw on one of your blogs. There's something about art in space.
Yes, art in space. Art in space was an awesome opportunity. So in November of this year, I was contacted by a friend of mine who runs the Playful Learning Lab at St. Thomas, which is a college here in Minneapolis, or in St. Paul, actually. And her lab had worked with the band OKGo to have this contest for kids to submit ideas for art in space. So art projects that could only be done in space. So like the tie-in to this, I believe, was one of their recent music videos that was filmed in the Vomit Comet in free fall time. So they had this contest. They had 2 winners, and then the undergraduate team in the Playful Learning Lab worked with the kids to create a version of their art in space idea. And then once that was finished, they were going to go up to the New Shepard rocket, I guess, which was part of Blue Origin, which was out of Seattle, I believe. And so at that point, it gets launched into space. It's not orbital, but it's in space for the launch is like 11 minutes, I think, or 12 minutes. They're in free fall, I believe, for about 3 minutes or something like that. And then it comes back down and lands, and then the payloads are retrieved. So they ran into a kind of classic engineering conundrum, which is we have a fixed amount of time. We have a deadline. And we have these projects, and these projects are kind of complicated, and we need some help. So she called me in to help out, and I spent a very intense week where I basically dropped everything and spent long days, longer like than I've ever worked like since undergrad, I think, and then helped them make these art in space projects. So one of them was a space guitar. So this space guitar was like the idea here was that one of the payloads would make sound. And then the other thing is that it would have like a paint splatter. So the paint would be up in space, and then it'd be in free fall, and then it would hit the walls and make this fun paint splatter. So like I was only brought in at the very end of this project, and so I don't know a lot of the details. But by the time I had gotten in, that paint splatter had been turned into like neon dye. So it looked almost like someone had like shredded open like an inkjet printer piece or laser toner. So it's like laser toner type dye. And so we get there, and here's the idea, and they have it all. And it was a week of kind of like Apollo 13 style, throw everything on the table. Here's what we have. And we need to get down to 500 grams exactly or less per. And we started out pounds over. And by the end of the week, we were able to get everything within space or within weight and in their payload boxes and everything programmed. And I think we were like a total of like 40 grams under between the two different payloads. And we had like an hour to spare before the last deadline for FedEx.
You said the guitar one. What was the other payload?
Yeah, so the other payload was, the idea was that there were magnets suspended in the, like, so these payloads were pretty small. They were like 4 inches by 4 inches by 8 inches or so, which is kind of like a standard nano lab spec for these things. And so the other one had magnets suspended in the middle, and at one end there were these magnetic particles of a variety of sizes, from like beads down to pretty small beads to ones kind of the size of a pea, I guess. And so for that one, what would happen is there were 2 fans, one at each end, kind of aimed at each other to make like a spiral of air inside of this thing. And then at the end, at one end cap, there were chambers. And then as the payload hit free fall, we get a signal from the rocket that then the program reads. And then the program opens up these pods one at a time, and then they all kind of go into the air, and it makes this like magnetic display that can only really happen in free fall.
Do these have cameras?
I
mean, how do you know if it worked?
Sure. So they started with cameras, and
but they weighed too much.
They started with cameras, but basically through the extremes of the design process, the cameras were one of the things that got removed. This is one of the parts where I guess I won't say regrets, but if I would have changed anything or had an extra week or something like that, I really would have liked to get the footage. But at the same point, when I thought about it, I'm like, that almost makes it more art, right? Like the whole point of this thing is not like, we're not collecting any data for science. This is purely, we as a species have evolved enough capacity that we can afford, that we can send children's art dreams into space for the sole purpose of being kids' art in space. And I'm like, that's pretty awesome. And so then we have this device that we sent up into space that has this space guitar with solenoids striking strings, and it's got this neon paint toner that's out, and it's got this whirling vortex of magnetic debris. And it's strumming away up in space, and no one will ever hear it, ever. And then it comes back down, and that song, so part of what drove the song for the space guitar is there's like a chamber inside of this nano lab that had these balls in it and a proximity detector. And when those balls went in, that would seed the random number generator. And then it took that and combined it with the telemetry in from the rocket. So we can definitively say that what played up in space will never, ever be played here on Earth, just because we can't reproduce that same seed. So to me, could they have cameras? Yeah. Were they going to have cameras? Yeah. Just sometimes engineering projects not end up exactly like you want? Sure. Is it more art for this to be played for an audience of literally nobody? Sure. Sure. Yeah.
It's a space philosophy project.
Exactly.
Okay, I'm not sure how I feel about that, but I can see what you're saying.
Yeah. I mean, surely you've had a project where at the end of it, you're like, that's a design decision that I wish I wouldn't have made, but now that I've made it, yeah, I can live with it. It makes sense.
I've had many bugs that were secretly features, or features that were secretly bugs.
Mm-hmm. Mm-hmm.
Well, Adam, I really enjoyed speaking with you, and hearing about your projects makes me want to go talk to some museums. Do you have any thoughts you'd like to leave us with?
I do. I would like to say, wash your hands, stay 2 meters away from strangers, and stay safe.
All right. That is very timely information. Our guest has been Adam Wolf of Wayne & Lane, Senior Engineer.
Thanks, Adam.
Thank you.
Thank you to Christopher for producing and co-hosting. Thank you to our wonderful patrons for Adam's mic. If you like the show and want to support it, please consider visiting us on Patreon. Also, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. Now, a quote to leave you with. This is from Daniel Goleman's Emotional Intelligence. Kind of an old book, but it's our book club pick. Circuits from the limbic brain to the prefrontal lobes mean that the signals of strong emotion, anxiety, anger, and the like, can create neural static, sabotaging the ability of the prefrontal cortex to maintain working memory. That means there's a good reason you can't get anything done. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.